As described in the previous module, the rate of a reaction is often affected by the concentrations of reactants. Rate laws, sometimes called differential rate laws or rate equations, are mathematical expressions that describe the relationship between the rate of a chemical reaction and the concentration of its reactants. As an example, consider the reaction described by the chemical equation lowercase a plus lowercase b times products, where a and b are stoichiometric coefficients. The rate law for this reaction is written as rate equals k times a to the power of m times b to the power of n, in which a and b represent molar concentrations of reactants, and k is the rate constant, which is specific for a particular reaction at a particular temperature. The exponents m and n are the reaction orders and are typically positive integers, though they can be fractions, negative, or zero. The rate constant k and the reaction orders m and n must be determined experimentally by observing how the rate of the reaction changes as the concentrations of the reactions are changed. The rate constant k is independent of the reactant concentrations, but it does vary with temperature. The reaction order in a rate law describe the mathematical dependence of a rate on a reactant concentrations. Referring to the generic law above, the reaction order m with respect to a and n in order with respect to b. For example, if m equals 1 and n equals 2, the reaction is first order in A and second order in B. The overall reaction order is simply the sum of orders for each reactant. For example, the rate law here, the reaction is third order overall, 1 plus 2 equals 3. A few specific examples are shown below to further illustrate this concept.